The supply chain is a complicated thing with many aspects. I'm just going to talk about the analytics or the math piece of a supply chain. And that is in no way because that is the only interesting or the most exciting part of a supply chain. It's just that I'm a math person, so that's the part that I'm going to talk about. Now, throughout grad school and applied math, I felt like everyone around me was constantly saying how everything we were learning could be applied in a supply chain. Supply chain, supply chain, supply chain. And I felt like the noob that was like, supply what? I'll admit that I did not fully understand how to apply analytics and math in a supply chain until I started working in the field. And it turns out the murmurs were all true. Analytics is extremely helpful in a supply chain. It can help companies save a ton of money by reducing waste and improving efficiency and just making things run a lot better by using the data. So in that context, what is supply chain analytics? Let's describe supply chain analytics in terms of something that we all know well, bread. So we're going to use the example of a baked goods company called the Yeastie Boys, and we're going to walk through how they've used analytics in their supply chain. Now, a supply chain can take on all types of forms, but we're not going to sabotage our explanation by making this intergalactically complicated. We're going to fight for our right to simplicity by using just the Yeastie Boys operation. Now, the Yeastie Boys make all types of baked goods. Bread, pizza dough, bagels, cookies, you name it, they make it. All those delicious carbs. Now, they buy all of their ingredients from a set of suppliers. And they make all of their own bread in 2 bakeries. Then, they send it from those bakeries to a set of distribution centers, where it's distributed out to the stores, where the customers can buy all of their baked goods. Now, every step of this, from buying the flour and the sugar to a customer buying a baked good in the store, all of those steps together comprise the Yeastie Boys supply chain. And there are so many steps to this, and so many ways we can use analytics to improve a supply chain. I am not going to go into all of them. I am just going to highlight the 10 ways that the Yeastie Boys have used analytics to improve their supply chain. Number 1, demand forecasting. So the Yeastie Boys have a really popular product called Rapper's Delight. And these Rapper's Delights are these wonderful sandwich wraps that are a huge hit with customers. People love them. But sometimes the Yeastie Boys make too many Rapper's Delights. And then on other days, they don't make enough. So how do they make sure that they have enough to meet the demand, but they're not making too many? Well, we can create what we call a demand forecast. This demand forecast will take into account all of this historical information and will forecast how many Rapper's Delights we need in each store on each day. We're going to use things like seasonality, like maybe more Rapper's Delights sell in the summer months. And we're going to use things like prices and promotions. Maybe we know that when they're on sale or when the price is a little bit lower, we sell more of them. So all of these factors are going to come into play when we create our demand forecast of our Rapper's Delight. We can create a demand forecast using statistical prediction methods and machine learning, and creating an accurate forecast is going to make sure that we avoid over and underproduction. Number 2, supply planning. Okay, so let's say that we have a good demand forecast, but that doesn't tell us how many we should make. It just tells us how many we think we're going to sell, which is slightly different. And it also doesn't tell us how many ingredients we need to buy from the supplier. Let's take another one of our popular Yeastie Boys products, the Pumper Nicki Minaj. All right, let's take our demand forecast for how many Pumper Nicki Minaj loaves we think we're going to sell in each store on each day. And in an ideal world, that forecast would be perfect, but we don't live in an ideal world, and we can't predict that forecast perfectly. So given that we don't know exactly how many we're going to need, how many should we make? Should we make a little bit more? And how much more? So that is our supply forecast. How many should we give each store, given that our demand is kind of uncertain? And then we need to use that to decide how many of each ingredient we need. If on Tuesday, say we're going to make 100 loaves of Pumper Nicki Minaj bread, then how much flour and rye and sourdough do we need? And given that we need that much, do we have that in inventory or do we need to order it? And if we need to order it, when do we need to place those orders? Because there's a lag time, a lead time in between when we place an order and when it actually is ready to be used in the bakeries. All of this contributes to the supply planning piece of a supply chain. Supply planning will use statistical methods, sometimes optimization, a lot of data management, and all of this is going to help us to figure out how much we need to produce over time and what we need to order and when in order to make those amounts. Number 3, inventory optimization. Now, some of the Yeastie Boys products, like the Pumper Nicki Minaj and the Rapper's Delights, those need to be made fresh and sent directly to the bakeries to be eaten as soon as possible. But let's say that they have some other products, like their Big Papadums. And these Big Papadums don't need to be eaten right away. They can last a little bit longer if you keep them sitting somewhere, like in the distribution centers, in inventory. So do we want to make a big batch of these Big Papadums so that maybe we avoid transition costs from making Big Papadums to then switching the lines over on the bakery to make Pumper Nicki Minaj? If we make one big batch, then maybe we'll save some money and it will be more efficient. But then we need to store it somewhere. But we also don't have infinite space in our inventory, and we don't have infinite time or money, so we don't want to make too large a batch. How do we optimize exactly how many we keep in inventory? This is inventory optimization, and it's going to use some mathematical optimization and statistical methods to try to find the ideal amount to keep in inventory over time. Number 4, network design. The Yeastie Boys have a new product, their Baby Got Banana Bread, and it is so popular. Their 2 bakeries simply cannot make enough of it. The demand, it's just so big. I can't believe it's just so round. It's like out there. So they either need to expand one of their bakeries or build a new 3rd bakery. And if they build a new 3rd bakery, where does that go? What's the ideal location? We need to take into account things like real estate costs and transportation costs, labor costs, and if we were to build a 3rd bakery, how would we shift our production in a way that adjusts for these 3 bakeries? All of these things need to be taken into account while making sure that we continue to meet demand. Making this decision is a classic network design problem that mostly uses mathematical optimization. And it can ensure that all of our facilities, our bakeries, our distribution centers, even some of our stores are in an ideal location to help us minimize cost. Number 5, build planning and production scheduling. Last week, the Yeastie Boys came up with a new recipe for a bread that they call Busta Rye. And they think Busta Rye is going to be a huge hit. But there are a number of things they need to figure out before they can actually start producing it. First, and kind of separately, they need to figure out how many Busta Rye loaves they think they're going to need every day in each store. And this is tricky because we've never made Busta Rye before, so we don't know how it's going to sell. So to create a demand forecast, what we can do is use a similar product. Let's say that last year we started making Cardi brioche buns, and we think that Busta Rye is going to sell pretty similarly to how Cardi brioche buns sell. So we'll take our current demand forecast for Cardi brioche buns and we'll tweak it a little bit based on business knowledge to create a forecast of our Busta Rye. The other tricky part is when and where are we going to make these Busta Rye loaves? We already have a baking schedule for our bakeries where we lay out which bread we're making when in which oven. So where in which oven are we going to make the Busta Rye? And when are we going to make it? It probably makes sense to make the Busta Rye either before or after making either the Pumper Nicki Minaj or the Pumper 50 Cent loaves, because then we won't have to transition as much of the equipment over because they have similar doughs. But which slot do we take? We can optimize this build plan or production schedule by thinking about things like which bakery already has a lot of the ingredients that are needed for Busta Rye. Or do we want to take into account how much time it takes to transition from making one bread to making Busta Rye? And we want to minimize that transition time. Or is there a bakery that there's a lot of oven time available? And so we slot Busta Rye into that time slot. All of these things are going to come into play to help us make sure that we're not reducing production of other breads while we're increasing production of Busta Rye. This is build planning, which is similar to production scheduling, and it's going to use optimization or optimization-based methods to try to come up with a schedule that's going to minimize costs or reduce waste while making sure that we're still meeting demand. This particular example of Busta Rye also deals with new product introduction, or NPI, which is another thing in supply chain that we can use analytics for. Number 6, supply allocation. One of the Yeastie Boys products that flies off the shelves is the Sit Down, Be Humble pie by Chef Kendrick. They simply cannot make enough of it, literally. There's too much demand. And they're trying to make more, but they need to shift things around at all of the bakeries in order to make more, and that'll take some time. So in the meantime, they don't have enough. Let's say that the Yeastie Boys can only make 100 sit down, be humble pies each day. And there's one store that wants 40, another store wants 50, and all the other 4 stores want 30 each. So how many do we give each store, given that we don't have enough? And how do we decide what fair is and what fair means in this context? Sometimes it makes sense to give each store equal amounts, but sometimes it doesn't. There might be some other things that come into play, like the actual demand at each store, or client loyalty, or profit sharing at each store. All of these things can be taken into account, and we can vary how much we give each store over time as well. This is called supply allocation, and it's going to take into account maybe some optimization or some statistical methods, a lot of data management, and a lot of just business knowledge to figure out how we allocate to each store to make something that's fair. Number 7, predicting risks and disruptions. Another super selling product from the Yeastie Boys is their Can I Get a Focaccia, which uses a very special olive oil that comes from only a single supplier in Italy. Now, in recent years, there have been storms in the region where the olive oil comes from, and those storms have meant that there has been delays in supply of this olive oil, so the sales of the Can I Get a Focaccia were greatly affected. Now, if the Yeastie Boys had taken that into account by doing some prediction methods, or maybe watching current news and weather forecasts to take that into account, then they could have stocked up on that special olive oil and maybe had enough so that their sales weren't affected. This is risk and disruption prediction, which uses statistical prediction methods and current event or news management to help reduce the impacts of unexpected events on supply. Number 8, pricing. Now, there's a cookie that the Yeastie Boys used to make called the M&M cookie. And the M&M cookie used to be super popular back in the early 2000s. And they stopped making this cookie for whatever reason, but they've recently decided the M&M cookie could be really popular again. So they're bringing it back, but they don't know how much to sell it for, at what price. So there's a number of things that they can take into account. They can look back at the early 2000s and see how much they used to sell the M&M cookie for relative to other cookies at that time. They can also take into account how much they're selling their other cookies for right now, and maybe even what competitors are selling similar cookies for. All of this can combine to create the ideal price. Pricing is going to use things like optimization, statistical methods, historical data, and possibly even competitors' pricing to help determine the ideal price of an item. Number 9, excess and obsolete inventory. A few months ago, the Yeastie Boys made too many Tu-pocket Pitas. These Tu-pocket Pitas are these pitas that have 2 pockets. They're kind of a cult favorite. Anyway, they made too many of them, and they're just sitting in inventory in the distribution centers. And there's this disagreement in the offices of the Yeastie Boys about whether these Tu-pocket Pitas are dead because they've just been sitting in inventory for so long, or whether they're still alive and they're good and they can do something with them. But even if they are good, they're not fresh. So what do we do with these excess Tu-pocket Pitas? Well, in the case of the Yeastie Boys, they decide that they want to sell them. But they can't sell them for the same price that they sell their fresh Tu-pocket Pitas because they're just not as good. So at what price do they sell them? This is called dealing with excess or obsolete inventory, or E&O, and it's going to use optimization and statistical methods to try to figure out the best thing to do with this excess inventory. Number 10, manufacturing and distributing. Another of the Yeastie Boys' popular products is their Milli Vanilla cookies. They're a huge hit. But there was a big scandal. It turns out that the Yeastie Boys weren't making their Milli Vanilla cookies in their own bakeries. Someone else was making them, and the Yeastie Boys were selling them as if they were making them in their own bakeries. But in the end, PR decided that it would be best if they owned up to this. And it turns out that it's cheaper to make the Milli Vanilla cookies in another bakery and just distribute them. So the Yeastie Boys are still selling their Milli Vanilla cookies, but they're made somewhere else. They're outsourcing production and they're just distributing them, so they still get a profit. These decisions, to be made between manufacturing and distributing products, requires descriptive analysis and possibly some simulation modeling to help figure out how to reduce costs. All right, so there you have it. Those are the 10 ways that the Yeastie Boys use analytics to help improve their supply chain operations. And it should give you an idea of how analytics can be applied in a supply chain, how it can help reduce costs and improve efficiency. And that is supply chain analytics.